Okay, so the next function is f of x or y equals -5 to the x. We have to identify what type of function is it. Excellent. Great. What is the base function? Or first of all, the base of the exponential. What is it? Careful. Yes. So an exponential function is a to the x. There are two possibilities for a. Either either greater than +1, or between 0 and 1. Not 0, not 1. So let me give you 3 examples. F of x 0 to x, f of x 1 to x, and f of x -3 to x. These situations are not exponential functions. Not exponential functions. Why? Because the base is 0, the base is 1, and the base is a negative number, which is not allowed. Question, why? Why isn't this allowed? Why can't I have a base of 0 and an exponential or 1 or a negative number? I can take -3 to 5, I can take -3 to 0, I can take -3 to 15, I can take 0 to the 4th power, I can take 1 to -3 or to 0 or to 5. How come that these bases are not allowed in an exponential function?
0 to any power is 0, 1 to any power is 1, and then depending on the exponent, it can be either negative or positive, so it would just flip back and forth.
That's a nice story, but that's not the reason. Well, the reason is the exponential function a one-to-one function? Here's the graph of the exponential function with the base greater than 1. So a to the x with the base greater than 1. And this is the graph of an exponential function. A to the x, in this case, is between 0 and 1. So are these two shapes one-to-one functions? By the horizontal line test, they are one-to-one. What does one-to-one mean? For any y value, there is only one x. For any y value, there is only one x. For any y value, one x. Right? So for this y value, only one x. For this y value, only one x. For this y value, only one x. That makes it one-to-one. Okay, and so what? What does that mean if it's one-to-one? It's a function, and it also has the property of being one-to-one. So what? What do we know about inverse functions? What do we know about one-to-one functions? Only one-to-one functions have inverse functions. So the reason is, if we use any of these bases, the inverse function, which is log, will not exist. That's the only reason why we had to exclude 0, 1, and negative numbers from the base of any exponential function, because the inverse function will not exist. So this is one-to-one, it will have an inverse function, which is log. This is one-to-one, it will have an inverse function, which is log. But the inverse functions will not exist if the base, there is no log function with a base 0, 1, or a negative number. And that's the reason why we had to exclude 0, 1, negative numbers from the exponential. Okay, so let's go back. So the base of the exponential is 5. So the function is 5 to the x. That's pure exponential. And there is only one transformation. The negative outside, it does not touch x. So it cannot be a transformation on x. This does not touch x. It touches the y value of the base function. So what transformation is that? So this is the graph of 5 to the x, like this. It continues forever. It does not touch the x-axis. We say eventually it may. But now what transformation is this? Yes, I agree. It flips the graph. So this is, since it's a transformation on x, or transformation on y, all the y values get multiplied by -1. Indeed. What if I want to look at this now? What transformation is this? Obviously not on y, because the negative sign touches x. Yes, from positive x to negative x, indeed. So it will be this. This is 5 to -x. Very good. So again, you have to choose here. Any questions on the exponential function? Yes, please.
Can you explain shrinking and stretching?
Yes. Horizontal, vertical? Okay. The vertical is easier to understand. The horizontal is the only one that initially doesn't make sense. So I can present both. Which one or both? Okay, perfect. So let's look at the following. F of x equals twice the absolute value of x, and g of x equals 1/2 the absolute value of x. Which base function did I use when creating f and g? The base function was the absolute value of x. Remember, this is what we like to call a v function. V function. This is the absolute value of x. So this is the absolute value of x. When I multiply all heights by 2, what will happen? Yes, vertical stretching, because all the heights get multiplied by 2. So it gets closer to the y-axis. What if I divide all heights by 2? Does it make sense? So this height gets multiplied by 2. And this is the new graph. So this one is twice the absolute value of x. The other one is when I divide the height by 2. So this graph will be 1/2 the absolute value of x. So that's vertical stretching or vertical shrinking of the graph. Stretching, shrinking. From the absolute value, stretching from the absolute value if the number is greater than 1, stretching if it's less than 1, shrinking. But that's vertical. So this is vertical, stretching, shrinking. The other one is exactly opposite of what you would expect, meaning the horizontal stretching and shrinking. And let me explain on, let's say, x cubed before I give you another example. Do you need this second one or not? It's up to you.
Yeah.
Okay, perfect. So what if I want to determine this function? I am given f of x, which is x cubed, but I really want to determine f of twice x. How would you determine f of twice x? You will replace x by 2x, correct? That's what this says. So you will have 2x raised to the third. But now you raise 2 to the third, and you get 8. And you raise x to the third, and you get perfect. So now, what did I do here? Is this a transformation on x or y? I should have asked this here first. Is this a transformation on x or y? Well, the absolute value is intact, so it cannot be a transformation on x. It's a transformation on y, right? Either we increase y or decrease y by a factor. I mean, or we multiply or divide. Okay, but here I multiplied x by 2, so this is twice x. And you would expect this to happen, right? Any x multiplied by 2 stretches horizontally, right? It's the opposite. Why? So forget about this for a moment. How do I graph 8x cubed? This is x cubed, correct? We just graphed x cubed a few minutes ago, right? How do I graph 8x cubed? Remember what we just did with the absolute value. Is it this? Or is it this? Is it vertical stretching? 8x cubed. Is it vertical stretching or vertical shrinking? Yes, right? Because it's like the same with 2x to the absolute value of x. So this is x cubed, and 8x cubed does this. But we actually multiplied x by 2. And we would have expected this to happen. It's the opposite. Because x cubed, when we replace x by 2, you get 8x cubed, which means this. So this is the only, I would say, difficult one to understand or remember. So if this is x cubed, this function, when we replace x by twice x, it will be this. So f of twice x is horizontal shrinking. You would have expected to happen the exact opposite, because I'm replacing x by twice x. How come that it's a horizontal shrinking? That's what it is. And if you want f of 1/3 x, this will be a horizontal stretching. We can illustrate this very nicely with trig functions. What is, because we're going to get to this at the end of this handout anyway. So sine x, what is the period of sine x? 2 pi. Perfect. What about sine 3x? What is the period of sine 3x? You should say 6 pi. It's 2 pi over 3. Okay, so the red graph should be, if we are correct, which we are not, much stretcher, right? Stretched much more than sine. It wouldn't have been the case. It would be like this, because the period is 2 pi over 3. So let's graph. I'm going to use just between, let's say, 0 and 2 pi, so you can see it better. With a scale of pi over 4. Okay, and I just want to make sure that the mode is radian. Yeah. The blue, the first graph, is sine x. And look what happens to sine 3x. So the period is not 2 pi or 6 pi. It's 2 pi over 3.
So the domain's never changed.
No, the domain doesn't change. The period changes. It repeats itself in blocks of 2 pi over 3, not in blocks of 2 pi. Very good question. I can't do this in pre-calculus. I have to wait for them till we finish trig before I show this. But with you, it's a different story. So that's why you saw only one period for sine x, but you saw many more. Because the period, the complete rotation is 2 pi over 3 for sine 3x. And we changed x into 3x. You would have expected this. Instead, is the period divided by 3. Okay, perfect question. I still have a couple of minutes. Okay, so let's look at number 9. So you are responsible between now and Thursday for the first 8 problems, and we'll see if we can finish number 9. Because I would like to graph it. I don't really care for plugging in numbers, but I would like to graph it, and hopefully in 3 minutes we can do that. If not, it's okay. We will pick up on Thursday where we left off. So f of x, 1 minus x squared for x less than or equal to 0. And I'm going to change this a little bit. I just want to show you something else. So let's say 2x minus 2 for x greater than 0. I just made a minor change. Okay, so what type of function is this? How do we call this function?
Piecewise.
Thank you. It's defined in pieces, right? How many pieces? 2 pieces. Whenever we are asked to graph a function, so here I'm asking you to graph it. The skills assessment will not ask you to graph it, but I need this for this course. Okay, every time I'm asked to graph a function, I'm looking at the domain first. So if I change this into interval notation, what will you say?
Negative infinity to 0 bracket, or yeah, bracket.
And for this?
0 to infinity.
Perfect. So now you can identify the domain for us.
Solving numbers.
Good. Let's create a table. Which is the key value of x here that is very important?
0.
Yes. How come that 0 is so important? 0 will always be in the table, but here it's also the key value because this function changes from this to this at x equals 0. See this bracket? See this parenthesis? I'm going to copy these and touching right under 0. Then I'm going to say that I'm going to ask you which function we use between negative infinity and 0. I know it's silly, but I want to write it here. So I want 1 minus x squared. Which function we use between 0 and infinity? 2x minus 2. Good. What type of function is this? And what type of function is this? Perfect. So let's say 1, negative 1. When I plug in negative 1, of course, to the left of 0, what do I get?
0.
Perfect. When I plug in 0, I get
1.
Perfect. When I plug in 0, you should say, no, you can't. Please bear with me. When I plug in 0, what do I get? And when I plug in 1, what do I get? Perfect. Let's graph it. The first order pair from left to right. Negative 1, 0, correct? 0, 1, correct? Full point or open? Thank you very much. And here's the graph. So it's x squared, negative x squared, up 1. Okay, 0, negative 2. You know we cannot extend it to the right. This piece is only between negative infinity and 0. 0, negative 2. What type of point?
Open.
Thank you. And 1, 0. This is the graph.